Today we're digging into something really important for a lot of people, getting an engineering education. And here's something wild. Did you know that only about 5% of students graduating with a bachelor of science degree in the US are actually engineers?
Wow, only 5%. That really puts it in perspective. It's quite an elite group you're joining if you're heading down this path.
Exactly. And our sources today, well, they're basically set up as a guide for navigating this, unique kind of education. So our mission here is to pull out the key strategies, the core insights to make that jump from high school to college smoother.
And really set you up for success, right? For a rewarding engineering career down the line.
Yeah, think of this whole deep dive as like a shortcut, a way to get really well informed about preparing for what's definitely a demanding path.
But also incredibly fulfilling, as the sources point out.
Definitely.
And one thing that comes through loud and clear is framing this education as a serious investment, a
Yeah.
really valuable one.
Right. So you need to think from day one, how am I going to invest my time, my effort, wisely?
It sets the stage for everything else.
Okay, so given that, we've got a lot to cover. We'll get into, daily study habits, managing your time,
Getting connected in the engineering world.
all the way through to planning for graduation. So, yeah, let's jump in. First off, that transition, high school to college. It's a big one for everyone, but maybe especially for engineering students.
Oh, absolutely. The sources really hammer this home. In high school, most of the learning, the core stuff, it happens in the classroom.
But college and engineering specifically, it flips. Most of the real learning, the deep understanding, happens outside the lecture hall.
Which means you've got to build totally new habits and maybe ditch some old ones that just won't work anymore.
And it connects to this bigger idea, doesn't it? How an engineering education fundamentally changes how you look at the world.
It really does. You start asking different questions.
Yeah.
How are things made? How do they actually work?
How can we make them better? Or even how do we design something completely new?
Yeah, and taking an idea just on paper and turning it into something real, something you can build, it's a whole new way of thinking.
And threaded through all of this is personal responsibility. That's a huge message.
Totally. Your success, your happiness even, in college, it primarily depends on you taking ownership of your learning.
Because nobody can actually make you learn, right?
Right. You have to be the one to engage, to seek out the understanding. That's a major shift for a lot of students coming straight from high school.
Okay, so if you're taking responsibility, that leads us straight to your biggest resource, your time.
The time management piece. It's critical.
There's this great analogy in the sources. Imagine someone just gives you $1 million when you turn 18,
Okay.
and they say, that's it, for your whole life. You'd budget that really carefully, wouldn't you? Look for every efficiency.
You absolutely would. Yeah.
Well, the advice is to approach your time in college, your education, with that exact same mindset. Treat it like that $1 million.
And there's a related point about the cost of not acting or giving up too easily.
Oh, yeah, that story was powerful. Tell us about that.
Well, there was this student, she was struggling in a class, not getting the grade she wanted, and she was thinking of dropping it. A $2,000 class.
Wow, okay.
And her instructor said something like, look, that's like buying a brand new laptop, having a little trouble installing some software, and then just throwing the laptop away.
Oof, yeah, that hits hard.
It really does. It shows that learning is often tough at first. But pushing through that struggle, that can actually become enjoyable, and it builds serious self-esteem.
Okay, so let's get practical. That 168 hours in a week, how does it break down?
Well, the sources give some pretty generous estimates, like 56 hours for sleep. That's 8 hours a night.
Nice.
21 hours for cooking and eating, 2 for grocery shopping, maybe 7 for personal grooming,
Okay, keeping track.
and even 14 hours for social time, relaxation, exercise, whatever. Add all that up.
And you get 100 hours.
Exactly. Which leaves 68 hours per week.
Yeah.
Still a huge chunk of time available just for your education.
68 hours. So if you have a typical, say, 16 credit course load, that's 16 hours actually in class, right?
Right. So subtract that, and you're left with 52 hours.
52 hours for studying, and the rule of thing they mention.
It's generally recommended, especially for engineering, to plan for 2 to 3 hours of study time for every single hour you spend in class.
Okay, so 16 class hours times 2 or 3. That's 32 to 48 hours of studying each week.
Which, even at the high end, 48 hours, still leaves you with 4 hours of discretionary time from that original 68. If you only need 32 hours of study, you've got 20 hours free.
That's actually quite a bit of buffer, potentially.
It is. And it's flexible. The sources make a point of saying this isn't rigid if you're an older student, maybe you're married, have kids, have a job.
Right, life happens.
Exactly. So maybe a 5-year plan makes more sense than trying to cram it all into 4. It's about budgeting your time realistically for your situation.
So, okay, we've budgeted all this study time. But it's not just about grinding nonstop, is it? What about breaks?
Ah, yes, breaks are crucial. Those 10 minutes or so between classes, they're not just travel time.
They're for resetting.
Pretty much.
Hmm.
Clearing your head. Our attention spans, honestly, they're not infinite. Taking even a short, deliberate break helps you refocus. It's actually healthy. Good for the mind, good for the body.
So how do you make sure you're sticking to this plan, identifying where time goes?
The practical advice is straightforward. Keep a logbook, a daily one.
Like actually write down what you do.
Yeah, track how you're really using your time. Then you can see where the waste is, where you're inefficient, and then you adjust your schedule.
And they mentioned using example schedules, right? Like a template.
Exactly. Something like the example freshman engineering schedule in the source material can be a great starting point. It's all about actively managing that million-dollar resource, your time.
Okay, solid foundation. That time management piece leads right into the specifics of daily studying. And the advice here seems pretty blunt.
It is. Start studying from day one. Don't ease into it. Hit the ground running.
And how do you structure that daily work? There's a cycle they recommend.
Yes, the read, attend, review cycle. It's really effective. First step, read. Before you go to class, read the material the professor's going to cover.
So you're primed. You know what's coming.
Exactly. You get familiar with it, and maybe more importantly, you identify the parts you don't get, so you know what questions to ask.
Okay, step 1, read. Then.
Step 2,
Mm.
attend.
Mm.
Go to class. Consistently. Even if the professor isn't the most dynamic speaker.
Ha! We've all been there.
Right, but they still offer extra explanations, context, maybe different examples in the book. And you focus on clarifying those tricky bits you found during your reading. Ask those questions.
Makes sense. Read, attend, and the last part.
Review. Later that same day, ideally, go back over the material again. Look at your notes, look at the text. This is what really cements the understanding.
Read, attend, review. Got it. But what if you do all that and you're still stuck?
Get help. Immediately. Don't wait. Don't let it pile up until just before an exam.
Use those office hours.
Absolutely. Professors usually want to help. That's why they have office hours. But you need to make an appointment or check their schedule and come prepared. Know what your specific questions are.
Don't just show up and say, I don't get it.
Exactly. And definitely don't procrastinate on seeking help. The sources had some, let's say, illustrative stories about that.
Oh, yeah. Like what?
Well, one student apparently emailed a professor at 10:05 p.m.
Okay.
asking for an extension on homework due the next day, admitting they'd only started it 5 minutes earlier.
Yikes. Not a good look.
Not at all. And another one, a student asked for a letter of recommendation, but had never actually spoken to or introduced himself to that professor before.
Ouch. These aren't just warnings. They're about building relationships too, aren't they? Preparation matters.
Massively. It shows respect for the professor's time and your own education.
Okay, speaking of preparation, let's talk notes. Note-taking. It's not just about lectures, right?
No, definitely not. You should be taking notes when you're reading the textbook, too. Highlighting, summarizing in the margins, whatever works for you.
And during the lecture itself, what's the goal? Transcribe everything.
No, please don't try that. You'll miss the bigger picture. Listen strategically. Identify the important ideas, the key concepts, the things that maybe add to the textbook or clarify it, complement your reading notes.
Any practical tips for the notes themselves?
Yeah, a couple of good ones. Use wire-bound notebooks. Simple thing, but it stops pages from getting lost or ripped out easily. Good habit for engineers who need organized records later.
Makes sense.
And study your notes soon after taking them. Like within the same day, spend an hour or two going over them. And this is critical. Make sure you understand the concepts before you dive into the homework problems based on them,
Why is that so important?
because it saves so much time in the long run. If you understand the why behind the method, the problems become easier. Trying to just follow examples without understanding is like using a shortcut that actually takes longer and doesn't teach you anything deeply.
Okay, so understand first, then practice. What about long-term recall?
Good point. Writing notes in your textbook margins helps connect ideas. Definitely keep all your engineering textbooks. They become valuable references. And maybe consider typing up digital summary sheets for key topics. Easier to search and link related concepts later.
All right, got the notes, got the schedule. What about where you study? the environment.
Super important. Find a comfortable place, good lighting, and the big one, no distractions.
So probably not in front of the TV.
Definitely not. And maybe think twice about having your phone buzzing right next to you or studying where you're likely to daydream. Keep the focus sharp.
What about roommates? That can be a big distraction factor.
It can. The advice is to talk to them. Lay out your study habits when you need quiet time. If you have the chance, rooming with another engineering major can be a huge plus. They just get the workload.
They understand the grind.
Exactly.
Okay, so individual study is key. But what about working with others? Study groups.
Study groups. They can be incredibly powerful if done right.
What's the key?
Well, think about this. The absolute best way to learn something deeply is to teach it to someone else.
Right, you have to really understand it to explain it.
Precisely. You need that solid grasp of the fundamentals. So the ideal way to use a study group is everyone studies the material independently first. Get your own
And
understanding.
you come together.
Yes. Then you meet up to discuss it, explain concepts to each other, work through problems together, challenge each other's understanding.
So it's active, not passive.
Absolutely. Everyone needs to come prepared and contribute. It's not a tutoring session where one person carries the group. And if you find you can't explain a concept clearly to the group, that's your signal.
That you need to go back and hit the books on that topic yourself.
Exactly. It's a great diagnostic tool for your own learning.
Okay, that covers daily prep. What about gearing up for the big tests, examinations?
The number one rule, no substitute for that consistent daily studying we've been talking about.
So no all-night cramming sessions the night before.
Please know, that night is for review only. Going over your notes, maybe some key problems. It's not the time to try and learn brand new concepts. Your brain won't retain it effectively under pressure like that.
So, review. What else?
Get a good night's sleep. Seriously, being well rested helps you think clearly. Ask your instructor beforehand about the exam format, multiple choice, problems, essays, how many questions, any specific areas to focus on.
Good intel to have. And during the test itself,
Read the questions carefully. If something seems ambiguous, ask the proctor or instructor for clarification if allowed. Tackle the questions you find easier. First, build confidence and momentum.
smart. Any way to handle test anxiety.
One good tip is to practice timing yourself when you do homework problems. Get used to working under a bit of time pressure in a low-stakes environment. It can make the real exam feel less daunting.
All right, so that covers the academic core. But there's more to succeeding than just books and exams, right? Getting connected.
Oh, absolutely. Joining an engineering organization is huge. The benefits are multifaceted.
Like what kind of benefits?
Well, networking, obviously. Meeting other students, professors, even professionals. But also things like plant tours, seeing engineering in action, guest speakers, bringing real-world perspectives.
Design competitions, social events.
Yeah, all that. Plus short courses, seminars to learn specific skills, sometimes even access to loans and scholarships specifically for members. It's a whole ecosystem.
The sources mention like 6 core purposes for these organizations.
You do, basically. 1, conferences and meetings for sharing ideas. 2, publishing journals and books to keep everyone current. 3, offering short courses on new tech.
Okay.
4, advising government on tech policy. 5, creating and maintaining safety codes and standards. And 6, providing networking for problem solving and finding jobs. It's pretty comprehensive.
So the message is clear. Find one relevant to your field.
Definitely. Look for student chapters of groups like AICE for chemical engineers, ASCE for civil, ASME for mechanical. Those are just examples. Go to a meeting or two, see what feels right, then join and get involved. Don't just be a name on a list. Participate.
Okay, getting involved is key. What about the formal plan, like your actual degree path?
Graduation.
Right, your graduation plan. You need to understand how admission often works in stages. First, you get into the university itself.
Step 1.
Then, often, after a year or so, you need to be formally admitted into the College of Engineering, usually based on your grades and foundational courses.
Step 2.
And finally, you might need separate admission into your specific major program, like electrical or civil engineering. Again, based on performance.
So how do you navigate all that?
Your academic advisor is your best friend here. Meet with them regularly. Understand the requirements for each of those steps. Map out all the classes you need for your degree, whether it's a 4-year or maybe a 5-year plan.
Know the prerequisites too, right? Which classes need to be taken before others.
Absolutely. And know when courses are typically offered, some might only be in the fall or spring. A program flowchart can be really helpful for visualizing this.
And it's not just engineering courses, is it? No, don't forget those social science and humanities electives. They're important for developing a broader perspective and fulfilling social responsibility aspects of your education. Plan those in too.
But plans can change if you discover a new interest.
Of course, it's a plan, not a prison sentence. You can always modify it as you learn more about different fields or your interests evolve. Flexibility is built in.
What about transfer students from community college?
Specific advice for them. Contact the university you plan to transfer to as early as possible. Understand their transfer policies, what credits will count, what the admission requirements are for transfers into engineering. Don't wait until the last minute.
Good practical advice. Beyond academics and planning, the sources mentioned a few other things, like volunteer work.
Yeah, if you could fit it in, even just a few hours a week, volunteering can be incredibly rewarding. It's not just about feeling good or connected to the community, though that's great.
It builds skills, too.
Definitely. Communication skills, maybe management or leadership skills depending on the role. Things that look great on a resume and help you grow as a person.
And civic duty, voting.
Simple but important. Exercise your right to vote. Be an engaged citizen. Understand how local, state, federal government impacts technology and society.
Makes sense. What about connecting with peers?
Just basic stuff, but crucial. Get to know your classmates, names, phone numbers, emails. You'll need them for study groups, or if you miss a class and need notes, build that network early.
And connecting with older students.
Also really valuable. Ask your professors if they can introduce you to some juniors or seniors in your program. They've been through it. They can offer amazing insights on courses, professors, campus life, internships. Invaluable perspective.
Let's bring some of this to life with those real-world perspectives.
Yeah.
Susan Thomas's story was interesting. She didn't start in engineering.
No, she was initially pre-med, but she realized she was less fascinated by the biology and more by the technology used in medicine.
Like the machines, CT scans, lasers.
Exactly, artificial hearts. That, plus her love for math and science, led her to switch to mechanical engineering.
And she mentioned being one of only a few women in her program. How did that play out?
Interestingly, she saw it as an advantage in some ways.
Yeah.
It made her stand out, maybe pushed her to connect more closely with her peers and professors, forming strong bonds.
That's a great perspective shift.
It is, and she really liked that Herbert Hoover quote. Something about engineering clothing the bare bones of science with life, comfort, and hope.
Nice. And her focus now is microtechnology.
Yeah, really cool stuff like developing painless microneedles for injections or even exploring tiny robots that could potentially target cancer cells. Her goal is R&D for cutting-edge medical devices.
Wow. Okay, then there was Suzelle Barrington, the professional engineer. What motivated her?
She loved math and science, but she specifically wanted a career that wasn't just sitting in an office all day. She wanted a challenge, yes, but also to get out, interact with people, contribute to society, maybe enjoy the outdoors sometimes.
So more hands-on approach.
Seems like it. She started out working for the Quebec Ministry of Agriculture, solving practical problems for farmers' drainage, building ventilation, stuff like that. Real-world application right away.
And she got her PhD while working. That's intense.
Extremely. Shows incredible dedication. But what I found really compelling was her view of engineering as letting your imagination run wild.
How so?
Using that imagination to solve problems, invent new technologies, make life better or more enjoyable. She loved that it involved site visits, talking to clients, not just calculations.
And she stressed the social side too, right? The
Yeah.
composting example.
Yes, the Montreal Composting Center. It was technically sound, but it succeeded because they thought about the people. They made it visible, easy to find, easy to use. It fit into people's lives. Key solutions have to be practical and user-friendly. Engineering meets human behavior.
She also seemed passionate about diversity in engineering.
Very much so. Promoting it to young women especially. She cited that statistically only about 20% of engineers in North America are women, and even fewer reach top management.
And she challenged some old stereotypes.
And that engineering is just for guys, or that it has to be hyper-competitive. She emphasized that modern engineering needs great communicators, people who work well in teams. Those skills are just as important.
Makes total sense. And her field is environmental engineering.
Right. Integrating different sciences to tackle problems related to our changing environment. She gave some simple examples of how you start thinking like an environmental engineer,
Right.
like actually measuring how much food waste your household produces, or just observing how soil and plants naturally filter water, thinking about systems and impacts.
Okay, so wrapping all this up, what's the big takeaway from this deep dive?
I think the core message is that an engineering education is this incredibly valuable thing. this major investment. And like any big investment, it requires active, thoughtful management.
Managing your time, how you study, who you connect with.
Exactly. It's not passive. You have to be intentional about it.
But if you apply these strategies we've talked about, the ones from the sources,
Then you really can set yourself up for not just getting through college, but having a genuinely fulfilling experience and launching a really rewarding career.
it's empowering, really. The control is largely in your hands.
It absolutely is.
So maybe one final thought to leave everyone with. Mark Twain had that great quote:
Oh, which one?
I have never let my schooling interfere with my education.
Ah, yes. That's a classic. And a powerful one for anyone in higher education, maybe especially engineering.
It really makes you think, doesn't it?
Right.
What is the difference between your formal schooling, the classes, the assignments, the degree?
And your actual education, your broader self-driven learning, your curiosity, your understanding of how the world works.
Right. So the question for you listening is, how will you make sure your education goes far beyond just your schooling? How will you stay that active, curious, lifelong learner?